Are you guys ready to do some math early on Monday morning? Of course you are. That's what I love about you. Let's get right to it. Let's not waste any time of our wonderful math class. Come on, guys. It's going to be a lot of fun today. We are studying this very day about the length and the area of similar regions. And really, I think there's an easier way to state that. That's the title heading in your book. But I would say it this way, that we're looking at largely the perimeter and the area of similar polygons. Now remember what polygons are. The last part of it, the gons, has to do with shapes, and poly is many. And in the case of math and shapes, many-sided shapes. And so we're going to be figuring out the perimeter, which is the area around, or maybe even just certain segments of that perimeter. It's the length. But as well, we'll be talking about the area. That is all of the square units, right? Could be footage, inches, meters, etc. But all of the area, the squared part that's inside, not outside and around, like around a fence, but inside, the area inside a fenced-in place. And so that's one way of looking at it. Before we get to it, I want to identify two important formulas, like we often do. Okay, the first of these formulas that will be vital to understanding really all we're going to be doing with this, guys, is proportions and ratios and proportions. And remember, a ratio is just a fraction, okay? Number on top, number on bottom. A proportion is two ratios, where you have number on top, number on bottom equals another fraction, number on top, number on bottom. And whatever's across from that equal sign corresponds to what's on the other side, whether it's on top or it's on bottom. And when it's all said and done, all we're going to do is cross, not multiply across, but cross multiply, and then we just solve from there. It's really pretty simple stuff, just like basically everything in this chapter up to this point has been. All right, so our two important formulas. The ratio of perimeter, okay, you have two shapes, and so the perimeter of each one is going to be on that side, top and bottom respectively, is set equal to the ratio of a side, a certain side of each one of those shapes that's being considered. And so you'll have the length of one side here and the length of one side on bottom, one on top, one on bottom, and they're going to correspond across from each other. Now I know my imaginary air ratio perimeter doesn't help much. It doesn't look very good. So let's get to the board, because I think it'll make a lot more sense then. Okay, I'm going to read these to you, the problems that we're going to be working, and as we often do even in school, but in class that is at school, but especially now, I'm so limited in my space that I have, I'm not going to be able to put every word up, but even in our classroom we often didn't do that for time's sake. And so listen very closely to what it is that I state. Number one, the corresponding sides of two similar triangles, so those are polygons too, many-sided shapes, and triangles are that, three sides for each one. The corresponding, or those across from one another, sides of two similar triangles are 16 inches and 12 inches. The perimeter of the first triangle that has the side of 16 inches is 55. And so find the perimeter of the second triangle, and we're going to call that P, at the bottom a 2, a sub, not a superscript. Okay? So we have two triangles, and we're given a side that corresponds one with the other, 16 inches and 12 inches. And the perimeter of the first is 55 inches of the first triangle. What is the perimeter of the second triangle? All right, so here's what we're going to do. This is our first time, and if you're a little bit lost right now, that's okay. We haven't done one yet, so don't give up before we start. It's actually very easy, okay? The ratio of perimeter is going to equal the ratio of sides. And if you want to write a formula, you might do it this way. Side 1 over side 2 equals the perimeter, okay, or the length length all the way around of the first, in this case triangle, over the perimeter of the second triangle. And so see how the side of that first shape corresponds with the perimeter of that first shape, and the side of that second shape corresponds with the perimeter of that second shape. Remember, what's so significant about proportions isn't necessarily where you put one piece, whether it's top or bottom. It's just that if you put that one piece of a certain one, make sure that the other detail of that same one is directly across from it. And so just like we have S1 over S2, we could have S2 over S1 as long as P2 over here was over P1. And it would be exactly the same thing. Remember how we did that? You can switch those as long as you also switch them in the second one. But let's just make it a staple, okay? Which I think makes a lot of sense. And let's just put S1 over S2, side 1 over side 2, equals P1 over P2, because that way the side and the perimeter of shape 1 and the side and the perimeter of shape 2 are across from one another, and that's what makes the math of it work. So the sides of the first one, or the side of the first one is what? How many inches? Side of shape 1, 16. So I'm going to put 16 on top over what's the side that I'm given of the second shape? 12 inches. So I have 16 over 12. Okay, equals, what's the perimeter of the first triangle? Do I know that? Perimeter of the first, yes, 55 inches. And so I'm going to put 55 on top directly across from side 1. They need to correlate. The perimeter of 1, shape 1, needs to be directly across from the side of shape 1. Now, the perimeter of the second one, do I know that one? No. And so P2, that's not P squared, by the way, that's not up top, but it's a 2 down below, meaning it's just differentiating from the first shape. So that's not really mathematically significant in terms of a mathematical process that we're going to apply to it. It's just an identifying feature, that number bottom right. So what do we do from this point? What we have is 16 over 12 equals 55 over perimeter, and that's of the second shape. Well, one thing we can do to make it simpler, notice that 16 over 12. Can I reduce that any? Yeah, I can do that. So why don't I just go right ahead and do that? Okay, 16 and 12. What goes into each one of those? 16 and 12. Those are both multiples of 4. Very good. And so 16 divided by 4 is 4. 12 divided by 4 is 3. And so we can just go ahead and reduce that and make our numbers a little simpler off the bat. Get out your calculators if you haven't done so yet. Okay, get out your calculators. In fact, I'm going to pause and go get mine. I forgot mine in the other room. Give me just a second. Yes, who's back? Back again. Sorry about that, guys. Forgot my calculator in the other room. So, here we are. What we have is a failure to communicate. That would be on major pain, right, Mr. Ken? So what we're going to do is now, guys, cross multiply. Cross multiply. What is 4 times P? 4 times P is 4P. Okay? And what is 55 times 3? I mentioned to you how we were going to need our calculators. We really don't need it on this first one, but we're going to need it for the others anyway. But I'll go ahead and punch in 55 times 3, and I'm going to be looking at 165. We could already tell that in our God-given calculators upstairs. But that's okay, because we're using these to finish up, because we do have some big numbers in this last chapter that we're going to be studying. So 55 times 3 is 165. And Kels, what do I do from this point? If I have 4P equals 165, how do I isolate or get P all by itself? Obviously, I divide by 4. Divide both sides by 4, which is going to cancel out my 4's on the left side, and that's what I want. P's all by itself. And I will cheat just a little bit. We will, even though we could do this in our heads. What are we going to have? 4 into 16, 4 times. 4 into 5, once. And so it's going to be 41 something. And then 1/4, 41.25 I'm going to say. But let's make sure that we're right, okay? 165 divided by 4 equals 41.25. So P equals 41.25. Now let's not forget, what are our units in which we're measuring, guys and gals? We are, in fact, measuring in inches. And so I want to put IN period for my units, 41.25. What think you about that? That's all we're doing in this unit. That is not hard, is it, at all? Simple stuff. Let's do a second one, and then we'll deal with areas, which is just a little bit more challenging. But even it, guys, you're going to love it. It's a breeze. It's simple stuff. Number 2, if I have, on this one, let me read to you because we have different shapes for each one. Number 2, if I have the perimeters of 2 similar hexagons. Hexagons. How many sides do hexagons have? Hex, similar to the number 6, because there are 6 sides in a hexagon. So the perimeters of 2 similar hexagons are 20 feet and 180 feet. So one is quite more sizable than the other. In fact, 9 times, you can tell just by looking at it. 9 times larger. The smaller hexagon has one side of 2 feet. And so find the corresponding side of the larger of the 2 hexagons. So here's the information that I have. We have perimeters of 20 feet and 180 feet. The smaller has a side of 2 feet. What's the side that is missing? We haven't been told of the larger. Now don't get confused before we get started. This is simple, easy as pie, guys. Write your formula down. S1 over S2 equals, that's your first ratio. The second ratio to form the proportion is P1 over P2. And just remember, that's terrible, isn't it? Look at that dirty finger erase, Nikolai. That's bad stuff. All right, S1, the important thing is just they're across from one another. So don't get hung up as, well, does P2 go here or P1 there? Just get your S1 across from your P1 and your S2 across from your P2, and it makes no difference. But it's easiest, I think, just to do 1 first, because we count that way, 1, 2, so 1, 2, 1, 2, and it's very simple. So, do we have information about sides? Let's see. We do know that the smaller, we'll call that S1, has a side of how many feet? 2. So we're going to put that in the place of S1. 2 over. Do we know the side of S2, the larger one? No, that's a question mark. And so that's going to remain S2. That's not a 5, remember, but an S. S2 equals, that's not a very even equal sign, and there we go, that dirty finger erase again. Caden, we shouldn't be doing that, should we? Do we know perimeters? We certainly do. What's the perimeter of the first one, which would be the smaller as we've arranged them? Perimeter of the first one equals 20. Do we have a perimeter for the second one, P2? We do. The larger perimeter of the hexagon, the 6-sided shape, is 180. Now, let's not forget that we can just go ahead and reduce if we want, if we see anything above. Now, it's not a cross like in multiplication. That's different, okay? Because in multiplication, then you end up multiplying across. In proportions, you cross multiply. And so in multiplication, a lot of times you'll look diagonally. You can't do that with proportions. It'll mess it up. But what you can do is look up and down and reduce. Will 20 go into 180? It certainly will do so. And how many times does 2 go into 18? 2 will go into 18 9 times, correct? And so we can make that a 9, all right? It'll go into it 9 times, and each has a 0, so we can just kind of ignore that. And so our new ratio is going to be 1/9. We can simplify that, and that makes things a lot easier right off the bat. So we're going to cross multiply now. We like our variable on the left side, so let's take care of that first. What's s times 1? S times 1 is just a single s. And I don't need to carry over s bottom base 2. I know that's referring to the second shape. All right, remember that's not a squared, it's not above, it's just an identifying characteristic, not so much a mathematical procedure. So I have 1 times s, which is simply s, or 1s, but we just write it as s, equals, what is 2 times 9? 2 times 9 obviously is 18. And in what units am I measuring all the way around? Feet. And so that side, okay, and now if we want to toss back in, we're talking about side 2. Okay, that's fine if we want to do that, or we can just leave it at s. Up here, if we want to toss back in, and we're talking about the perimeter of the second one, that's okay. We can do that if we want, or you can just leave it as p and leave it as s. That's just being a little more specific, and mathematically we tend to like a little bit more information as opposed to not enough. Okay, for numbers 3 through 5, we're going to deal with a new formula that is very similar in concept. For numbers 3 through 5, we're going to be working the ratio of areas relative to the ratio of sides. And here's our formula, guys. That the ratio of areas is equal to the ratio of sides, but can you see this important number right up here? The ratio of sides squared. The ratio of sides squared. And so what we're going to have is basically the same formula that we had before. It's going to be S1 over S2. Okay, and that just means the side of the first shape over the side of the second shape. That doesn't mean to the first power squared. Equals A1, instead of perimeter, area, A1 over A2. But here's the one difference. Our formula says that those sides have to be squared. And that's not a little 1 or 2 at the bottom. That's a 2 up high, which is mathematically significant, and that means the sides are being squared. But we're doing the same thing, guys, really mathematically. The one difference is the sides are going to be squared. All we're going to do is take the top number times itself and the bottom number times itself to simplify that parentheses and then a squared outside. Okay, let's do an example of this, and I wrote that on 4. Actually, we're still over here on 3, aren't we? But I'm just going to write the same formula, and I'll write it here too, so that'll just save us when we get over there. So for this first one, I'm going to have in parentheses S1 over S2. Those are just identifying characteristics, the first shape, the second shape, and the side of each. But this is mathematically significant. We're going to square those two numbers. And then we're going to set that equal to A1 over, boy, that's some good sauce, isn't it? Love me some A1 sauce. Over A2. Those are just identifying characteristics. Area of side, or area of shape 1, area of shape 2, those are not mathematically significant. Now, let me read to you number 3, because again, we're dealing with different kinds of shapes. The first of 2 regular pentagons. So it's a shape with gons, or 2 shapes, gons, with how many sides? Penta. 5. That's exactly right. 5. Very good. The first of 2 regular pentagons has a side of 4 centimeters, and the second has a side of 3 centimeters. What is the ratio of their areas? Now here we don't have to find the areas themselves, so we really don't have to calculate it, thankfully, this time, because we're going to be given the areas of each once we do this mathematical process of the sides based on the info we're given. Okay, based on the info we're given. And we're going to do that in the order that we've been given them, S1 and S2. So what's the side of the first one? 4 centimeters. So all I'm going to do is put a 4 on top. What's the side of the second one? 3 centimeters. I'm going to put that on the bottom. How do I figure out the ratio of the two areas, I have to take this number, 4 over 3, and what do I do with it mathematically from our formula? I square it. Okay? Which, all that means is I can write it this way if I want. Remember what we did with radicals? And when you have it, the same thing being done to all of it inside, you can actually break it up. And that's exactly the same thing. 4 squared means 4 times itself, so 4 times 4. And then what we're going to have is 3 times itself, 3 squared, which is 3 times 3. Okay? So let's do exactly that. I'm going to write it right down here. What's 4 times 4? 16 over, what's 3 times 3? That is 9. So guys, my ratio for the area of those two pentagons, 5-sided shapes, is 16 over 9. That's as easy as pie, isn't it? No pun intended. Number 4. The first of 2 similar polygons, so we're not told what these shapes are, it's just that they're gons, shapes, and poly, many-sided. The first of 2 similar, not pentagons, we already did that, polygons has a side of 3 centimeters and an area of 10 centimeters squared. The corresponding side of the second shape is 5 centimeters. So what is the area of the second polygon? So the first shape has a side of 3 centimeters and an area of 10 centimeters squared. The side of the second shape is 5 centimeters, but the second shape, we don't know its area. That's what we're trying to figure out. Our formula is S1, side 1, over S2, which is side 2, and then mathematically significant is the square of both of those numbers as that fraction on the outside. And that'll be equivalent to our area of the first shape over our area of the second shape. Well, let's just plug in the information that we have. And let's do it in the order that they're introduced. And since 3 centimeters as a side is the first side that's introduced, let's plug that in for S1. So we will have 3 over, do we have the side of the second shape? Certainly we do. 5 centimeters, so we're going to put 3 over 5. Guys, don't forget this though, when we're not dealing with perimeter, now it's with area. And what do we do with our formula with that 3 over 5? We have to square it in order for it to be true of our area. Okay? And then that is going to be equal to, do we have an area for the first shape? We do. It's 10 centimeters squared. And so we're going to put that over here, 10. And that's going to be over, what's the area of the second one? That's a good question. If we knew that, we wouldn't have number 4 as a problem, would we? So we have to retain our A2. Remember, that's not A squared because it's a bottom one. It's just an identifying characteristic. It's just saying the area of the second shape. Now what we're going to do from this point, and I'm not going to write it out like I did here. Let's test ourselves a little bit if we understand what 3/5 means. All it is the 3, not times 2, guys, but 3 times itself. It's squared. And on the bottom, not 5 times 2, but 5 times itself, which is 5. Okay. So, what is 3 times 2? And I'm just going to kind of draw a line right here so you know I'm not... Does that make sense where we're not running into each other? I know it's cramped space, so please forgive me, but once again, I'm working with what I have. I know you're doing the same. What's 3 squared or 3 times 3? That's 9. So we have 9 over, what's 5, not times 2, but 5 squared. 5 times 5 is 25. So 9 over 25 equals, and look, there's no math to do over here yet. We just keep our 10 and put that over A2. Now, guys, all that we do is cross multiply. Now, don't look at that 25 and 10 and say, oh, we can reduce that. Well, it's true, they're both divisible by 5. However, when you're doing ratios, you can't reduce across. It messes everything up. It's the opposite of multiplication, regular multiplication. You can only reduce above and below, and there's nothing that will reduce there, so we're not going to try to reduce anything, or else we'll get all squirrely in our numbers. Let's do variable first, because we like that to be on the left side. What's 9 times a? 9 times a is 9a, which is equivalent to, what's 25 times 10? 25 times 10 is just 25 with an added 0, 250. From that point, we have 9a equals 250. Let's say, eeny, meeny, miny, Joey. How do I separate that 9 and that a? Well, they're being multiplied together, and so I have to divide both sides by a, which is going to cancel out my 9's on my left side. And I'm going to go right back over here to write the answer, okay? I'm like a Hebrew, working from right to left. So I'm going to divide 9 into 25. I'm going to grab my handy dandy calculator. You feel free to do the same if you like, and as well on your quizzes, as well as on your tests. So what we're going to have is 250, correct? 250 divisible by 9, which is as an answer, and we've been around, we've done some, I know, to the hundreds. Remember what I said, if you'll just do to the tenths on these, most of them anyway, I mean, that's fine. I'm not going to count anything off on any of them. Unless it specifically says to a whole number, or to a hundredths, or to a thousandths place, just do to a tenth, if it's not a perfectly whole number. So what we have, guys, is 27 point, rounded off to the nearest tenth, 8. A equals 27.8. If we wanted to get a little more exact, we could say that's A2, which is the area of the second shape. Again, not A squared, because then it wouldn't be done, but A2, area of the area of the second shape. 27.8 what? I'm going to say 27.8 gauges, tens. I hope not, guys. We already have too many of you folks. The area of the second shape is 27.8 centimeters, but because it's area is always measured in units what? Units squared. And so our answer is, it's an ugly 2, I can't take it, but it's 27.8 centimeters squared. Okay, let's do number 5, and we'll call her quits. What we have in number 5, let me read that to you. Sorry, I keep just trying to read it from the board, but we have more information that's significant. Okay, number 5. The areas of 2 similar pentagons. So we're dealing with 5-sided shapes again. The areas of 2 similar pentagons are 400 millimeters squared and 100 millimeters squared. One side of the smaller pentagon is 9 millimeters. Find the length of the similar side of the larger pentagon. Now let's not get all confused and angry and upset at life just because it sounds kind of hard, because it's really not that hard. It's very easy. Our formula, let's write first, since we're dealing with area of similar regions or similar shapes, polygons, we're going to have in parentheses S1 over S2, and that's going to be squared because it's dealing with area, will be proportional to the area of the first over the area of the second. They're across from each other, 1, 1, 2, 2. Beautiful. We're in good shape. So, do we have the sides, okay? Do we have sides that are given to us of each? Well, we're told the side of the second, and so let's call that S2. The wording is side of the second. That makes sense. 9 millimeters, okay? And so we're going to put that on bottom of the first ratio. 9 on bottom because the side of the second, or S2, is 9. The side of the first, do we know that one? No, we do not. And so that's going to be S1. All of that, why did I do that so big? That was dumb, wasn't it? So let's do all of that squared, because that's what our formula says to do, will be equivalent to the area of the first one. Okay, the area of the first one. We had that, don't we? 400. 400 over the area of the second one. We have that one. 100. Okay. So now what we're going to do from that point is we're going to simplify what's in parentheses as order of operations that needs to have that exponent applied inside so we can rid our problem of the exponents. What is s squared? Remember, just do each one individually is the easiest way to do it. What is s squared? S squared is s squared. That's not too hard, is it? Over, s squared will be over. What is 9, guys? It's not times 2. Don't try that. It'll be marked wrong faster than anything you've ever seen that's super duper fast. What's 9 times 9? Not 9 times 2. 9 squared is 9 times itself. 9 times 9 is 81. Very good. So s squared over 81 equals. Now I want you to look at something. In a proportion, different than straight multiplication, where in multiplication you can reduce, across, but here what we're going to do is reduce up and down. How can we reduce 400 over 100? Well, what we can do is just get rid of the zeros of both. They both have 2 zeros, so that's just going to leave us with 4 over 1. Well, that makes it a lot easier, doesn't it? Because 400 divided by 100 is 4, or 4 over 1. So what we're going to do in this case is just put right down here what we've reduced 4 over 1. And now from that point, what we're going to do is we will multiply crossways. Not multiply across, but cross multiply. What is s squared? All right, what is s squared times 1? Man, that's easy. Maybe the easiest thing we've done all day. Is s, don't forget, squared. Okay, that squared is still attached to it, and that's going to be important. What is 81 times 4? I'm trying to combine numbers there, contract them. That's English coming out of me. What is 81 times 4? Well, it's pretty easy, because 4 times 1 is, and we can go ahead and set this equal to, 4 times 1 is 4, and then 4 times 8 is 32. Yeah, that's not very neat. Let me redo that, please. Slam, bam, thank you, ma'am. So we're going to have 324, because 4 times 1 is 4, and 4 times 8 is 32, 324. And so most of these are that way. Even though they're relatively large numbers, we can still easily do those in our heads. Now guys, I have s squared. That's not s2 down here as an identifying characteristic. That's s up top squared, which tells me that that's an important mathematical process. And how do I get rid of a square so that I can isolate s and just solve for s? What is the inverse or the opposite mathematical operation of a square? That is a square root. And so I'm going to take the square root of both sides, and the importance of doing that is that gets rid of my squared with my s. And so now all that I have is an s. However, to do such a paramount thing, I must, well, of course I've come all the way over here without my calculator again, doy. The way that I do that, guys, is I go to my calculator, okay, and I find, of course it's probably going to be in a different spot than what yours is if you have one of the, what is it, T81 or 82, something like that calculators. But on my smartphone, I have a calculator app that's a scientific one, and if you'll notice, this one is a square root symbol, okay? And so all that I do is now just punch in 324. What's the square root of 324? That is 18. In other words, it's 18 times 18 that gets me to 324, which who cares by this point? All that it is about which we care is that the square root of 18 is or square root of 324 is 18, and that's all we need for our answer. So let's write it down and get out of Dodge. So here's what we have. We just solved for S1. We really don't have to write this, guys. But I like to, once again, give a little more information as opposed to being a little shy in the info that we ought to have. What kind of units and what kind of units are we measuring? We've been doing millimeters, and even though we dealt with area to find that side, our answer is not in area, and therefore it's not going to be in units squared, but it's just going to be in millimeters. And we already used the two areas that were squared. Since we solved for a side, it's simply in units and not units squared. And those units are properly for side 1, 18 millimeters. So that's our math lesson, guys, for the day. I hope you enjoyed it. More importantly, I hope you understand it, regardless of your level of enjoyment. Keep working, guys. We're almost through. I hadn't mentioned this to Algebra 1, but guys, this is the last chapter. Of course, that wasn't the original plan at the beginning of the year or even a couple weeks ago. But we've been dealt a hand that has been quite challenging, to say the least. You have been, I have been, we all have been. But thankfully, we're all in this together. You guys know that I'm on your side, which means I'm not against you. I am for you. I am pro my 7th and 8th graders. I appreciate you guys and your hard work. And so we're going to conclude with this chapter. We're not there yet, okay? But we're going to conclude with this chapter. And from that point on, it's just going to be review for the remaining about couple of weeks that we'll have left then. What I do need to tell you guys is that our next quiz is officially assigned. And the reason for that is we've done the 4th section, and typically it's 2 sections quiz, 2 sections quiz, and you know that's just your homework of 11 questions. It's assigned today, which means it's going to be due on Wednesday. So continue to get that math homework to me. Keep working hard on it. I have several of you that are doing very, very well. And then I have a couple who aren't turning things in. Guys, that's your grade. Remember, I know it's not easy, and believe me, I'm being lenient, very lenient. I'm giving you 100% corrections. And what I mean by that is taking 100% credit from those corrections. So please take advantage of that, because it is your grade. And work hard, and even though the circumstances aren't easy. And I know that you guys are willing to do that. I have confidence in you, but there are still a couple of you that I need to see more of that in. So appreciate you guys, love each of you, and that is all for math for this day.